Hello everyone, I'm Martinus Bagus Wicaksono, and in this video I would like to explain about DC motor PID control system. So here the purpose of this project is to maintain the speed of DC motor at the set point using PID control system via Arduino Microcontroller. The component that I use is here. This is the power supply, and then this is the controller Arduino Uno, and then here the motor DC driver. This is DC motor with encoder, and this all is a belt conveyor. So we will use this belt conveyor and then control the motor using PID control. And for the schematic, I still use the same schematic with the that I use in the open loop control system. So here this is the microcontroller, and then DC motor with rotary encoder, and this is the DC motor driver, and the last is the power supply. And following the schematic diagram, and we can wire those all components. So after we set those all components, and then we have this kind of system. So after we finish with the wiring, then we can test the system. In the testing system, we have this kind of serial monitor and also serial plotter of the system. This is the serial monitor, and these are the serial plotter of the system. The blue line here is the set point of the speed, and the red line here, this is the actual speed, and then for the green line here, this is the actual PWM. So basically when the speed is decreased, then the PWM is increased to maintain the speed closer to the set point that we have here. Okay, next we can go to the source code, microcontroller source code. So here we have this microcontroller source code here. In the hardware, the encoder is connected to pin number 2 and pin number 3 of the microcontroller. And then for the motor direction, I connected to the pin number 7 and 6. And for the PWM is connected to the pin number 5. And here the parameter that we use in this source code. And then this is the pin mode declaration. And next here we have the constant of P, I, and D. Here for P, I set it to 0.7. For I, 0.15. And then for D, is set it to 2. And then for the speed, we set it to 40 here. And this is the equation of the PID to calculate the error. And The last is the serial print of the output that it will display on the serial monitor and also serial plotter. Okay, next we can connect the hardware and then upload the program or the source code to the microcontroller. So here, first I will set to 30 for the speed. Okay, we can upload to the microcontroller. Compiling and now uploading. Okay, it is uploaded already. And next we can check the serial monitor here. So this is the serial monitor that we have. This is the value of the PWM, and then sorry, this is the speed, and then this is the PWM, and also the actual speed. So we can check through the serial plotter here, and then here we will have the graphic. This is the PWM, and this is the actual speed, and the blue line is the set point. So we can change the speed so that it will have the smooth graphic. Let's say we put 50 for the speed. Okay, this is the plotter, serial plotter. Next, we can apply load to the motor, and then we can check the relationship between PWM and also actual speed here. Now we can apply the load. As we can see, when the actual speed decrease, then the PWM increase. And then when the speed is increased, then the PWM here decrease. Again, see, when the actual speed is decreased, then the PWM increase at the maximum. And then if we have the speed increase, then the PWM start decreasing. The speed decrease, PWM increase, and then the speed increase, PWM decrease. Okay, this is the end of my explanation. Thank you for watching the video.